We're going to start with the basic combinations, like the basic operations: add, subtract, multiply, and divide. So those would be sums, differences, products, and quotients of functions together. Like I said, you don't necessarily have to copy all these things down. The way it's represented on the right side is what your Algebra 2 book wrote it as. Like f of x plus g of x. Their own separate function notations. Just be aware that your pre-calculus textbook will put the f and the g together through operation f plus g, f minus g, f times g, and then it'll just put 1 of x behind it. Okay. This is something we talked about in Algebra 2 as well, and we're going to talk about this today because we're going to be focused on domains. When in the basic ones, we don't really have too much issue with domains. When we get to division, there's usually an issue of domain because what are you not allowed to do in division? You're not allowed to divide by 0. So if you can find any x value that would make your denominator equal 0, you're going to have an issue, and that's going to be a restriction to your domain. So if you want to write a note to yourself about that, f divided by g, okay, go ahead and do that, but you'll have restrictions to domains in that case. Before I go on to the next slide, what are other issues of domain that you have experienced in Algebra 2? Besides you can't divide by 0. What else can you not do? She's saying this.
What is it?
Square root.
In the denominator.
Could we have a square root in the denominator? I don't see why not. We divide by square root. It's a radical. A square root is a radical. But I could have a radical in the denominator. Oh, in a final answer, you would rationalize your denominator, yes. But that wouldn't be an issue of domain. Like, it could still be a number. So this is like, what are functions where you have issues where you can't put all the x's in and get answers back out? Anything else you can't do with numbers? Can't square root what? Dylan says? Negatives. In fact, you can't square root, can't fourth root, can't sixth root, can't even root a negative. Can you take an even root of 0? What is the square root of 0? Okay, yes, you can square root 0. It is 0. So let's remember that. Okay? And one that's really, I would expect most people to know you can't square root negative numbers. One that you also learned in second semester last year, Algebra 2, was can't take logs of negatives or 0. Okay, so you have 3 things that you already know about causing issues with domain. So let's remember that through our notes today, that anytime we see division, anytime we see even roots, if we were to see a log in a function, we'll have to think very thoughtfully about what our domain is. Okay? Why don't you and your groups work through these 4 problems for me? So we're going to let f of x be 5x squared plus 2. We're going to let g of x be 3x minus 4. And I want you to do sum, difference, product, quotient. Okay. At the end, we'll go back and we'll talk about their domains. Okay, but you guys go ahead and do the sum, difference, product, quotient. Okay, work it out. Compare your answers. If your group disagrees, try to convince each other who's right. pretty easy. Review from really Algebra 1 and Algebra 2. Okay, I got the first one up. Most groups have that one done. I heard this group right over here communicating very nicely and talking about if you're adding or subtracting, you're just combining like terms, right? Good. I love it. That's the function notation. So instead of saying f of x plus g of x, the pre-calc book is shortening it to say f plus g of x. It's still a function notation.
Yeah. That's divided by G.
So what is it asking you to do? I would write it out. Write this one times, right? You don't have to multiply like terms, you have to multiply all terms.
Well, no. So that would be the 5x squared. Yeah.
In division, seeing like cross things out is just factor in the numerator and factor in the denominator. And that's all I have to do. They're being multiplied together. So like 5x plus 2, those are both terms. And that can't be factored. So 5x plus 2 will be factored. And then later you have Okay. Take a look at the board. Double check that you have the correct answers.
It's minus 8.
Oh yes, it is -8. In both classes, I've done my math wrong in my head. -8. Thank you. Okay, check your answers. Do I have any other mistakes? To make sure that you are right. Think about always like subtraction. I know you guys know how to subtract things. It's just like on that summer packet quiz 1.1 to 1.4. If you're subtracting a function made up of terms, you have to remember to subtract all of the terms. So that would be distributing your negative. So if you're one of those people who distributing negatives is always something you forget, you can show your distribution, you can add the opposites of all terms, but make sure that you're able to really think through that very carefully. Multiplication, you're basically just doing distribution or foiling. And then in division, I just want to really quickly say something about that. This is the one that, like, my Algebra 2 students, you guys did at the end of last year. It's a rational function. And Algebra 3 students you probably covered in first semester. But I always warn my students, like, don't get cancel happy. So some people will see 5x squared plus 2 over 3x minus 4, and they'll want to reduce 2 over 4 to be 1/2. But 2 and 4 are terms in the numerator and denominator because they're being added or subtracted with something else. So you can't cancel terms, you can only cancel common factors in the top and the bottom. Neither of these, 5x squared plus 2 or 3x minus 4, really factors any further. So they're not the same factor and it's done. Like, that's your answer. I'd say the majority of the time we have you do f of x divided by g of x. You put one in the numerator, you put one in the denominator, and there's nothing to reduce. Okay. Let's go back and talk about domains. Okay. Okay, first let's talk about f of x. What type of function is f of x? Nikki? Quadratic? Brennan, what is the domain for a quadratic?
Negative infinity to positive infinity.
Negative infinity to positive infinity. Excellent. And what type of function is g of x? Kylie? Type of function. This one was quadratic, linear. And what is the domain for a linear function? JJ? Domain for a linear function. The line goes forever in both directions, right? So negative infinity to positive infinity. Excellent. The majority of functions will have domains of negative infinity to positive infinity. The only ones you would be worried about, dividing by 0, even roots, logs. Okay? Okay, so if you take a quadratic and a linear and you combine like terms, what type of function is your answer, Zach? What type of function is this? It's quadratic. A quadratic has what domain? All real numbers. We've already gone over that. So by adding, subtracting, and multiplying, in multiplying we don't end with a quadratic. Abby, what type of function is this multiply? Cubic, which is a type of polynomial. Adding, subtracting, and multiplying, in these cases, our domain remains negative infinity to infinity. These, we don't see any of these issues popping up until we get to division. So remember, what's our issue with division with functions? When we see division, we're troubled by tell your group, what's your issue with division? What can you not do? Okay, work with your group to determine the domain. Write that in interval notation. Always put our domain in interval notation. Use interval notation to represent your domain. You guys decide your domain? So what is your issue with division? Okay. So you're focused where? Like it just have to come up with a domain. Well, 0 I actually could plug into this one because then I will get negative 1/2, which is an answer. So what is the thing that will make your what equal 0? Numerator or denominator? It's an issue of the denominator being equal to 0. So you have to think more carefully about what x makes your denominator equal to 0. Come up with a domain. Did you guys come up with a domain? What's your issue with this one? Yeah, so the denominator can't be 0, so we're focused on the 3x minus 4. And there's a couple ways to go about this, but what's one way that you could find out what x value makes 3x minus 4 equal 0? So equation and solve it, and that tells you what you want to exclude, right? Okay, hopefully you and your group members talked about this first bullet point over here on the sideboard. Anytime you see division in your answer, you're going to have an issue with domain because your denominator cannot equal 0. It's not that your answer is always x can't be 0, because I could plug x equals 0 in, I will get negative 1/2, and that's an answer. I'm worried about my denominator equaling 0, which is 3x minus 4. Set it equal to 0. Solve x equals 4/3. Makes that equal 0. So that would be a bad number to put in because I would have something undefined. In interval notation, how do we say x does not equal 4/3? Bracket is including. So if we don't want to include 4/3, we're going to use a parenthesis. Where should we start? Negative infinity. Go all the way up to 4/3. Skip 4/3 and pick right back up and go all the way to infinity. Everything works except 4/3. Side note, just so you're okay with this, if you had like x could not equal plus or minus 2, like let's say there were 2 things it couldn't equal, you would use interval notation. And if you're going to exclude 2 things, instead of having 2 groups, you're going to have 3 groups. So you would say negative infinity to negative 2 in union with negative 2 to 2 in union with 2 to infinity. So you need to like pick up every time you want to skip something. Okay, let's talk about compositions. The last type of combination of function. We'll do a couple examples and then you'll have some time hopefully to work on your homework assignment. A composition is when you substitute one function in for x in the other function. There are 2 notations. You've probably seen the notation on the right with the parentheses. The textbook uses the open circle. It sort of looks like it says fog, but it's just an open circle. And it means the same thing, f of g of x. So I say it the same way. Your domain ends up being the overlap of your answer, your composition, and the domain of your input function g of x. We'll see this play out in our example when we need to like shrink our domains. This is why I gave you that warm-up today where I did like f of 0 and f of x plus 1, because now instead of having 0 or x plus 1 in there, I have a g of x. So that's the thing that you're plugging in for x, and you would put it in a group of parentheses if necessary. Oops. Let's look at our first example. We're going to do let f of x equal x squared minus 4. and g of x equal the square root of 4 minus x squared. Okay, we're going to do f of g of x. Which means we're going to take this g of x, the square root of 4 minus x squared, and we're going to plug it in for x. So that's the square root of 4 minus x squared. Then I'm going to square it and subtract 4. Simplify it. I hear some murmurs. The square and the square root will cancel. So we've got 4 minus x squared minus 4. And then your 4's cancel, so we have negative x squared. So this is our f of g of x. Okay. Now what type of function is f of g of x? That's quadratic. What's the domain for a quadratic? Negative infinity to infinity. But before you write that down, you have to remember that in order for you to have done f of g of x, you had to be able to do g, get an answer back out that you could plug into f. So you'll always have to go back and check it against your domain for g. I instantly see that I'm going to have an issue here because I have what? Square root. So I've got to think about what's the domain for g up here. What are numbers you can't take square roots of? Negatives. If you have 4 minus x squared underneath your square root, what values of x squared will not be acceptable? Things that are less than 4? So I wouldn't be able to do 4 minus 1? I could do that, couldn't I? That would be the square root of 3. That's an answer. Greater than 4. Could I do 4 minus 5? No, because then I would get a negative. Could I do 4 minus 4? Yes, because then it would be 0. So if x squared can be 4, and it will still work, and that's like the lowest or the highest number that will work, what would the value of x be? If x squared could be 4. Twos. If I put 2 in, that will give me 2 squared, which is 4, and that works. But if I put in 3, 3 squared is 9, and that doesn't work. Algebraically, you could do 4 minus x squared equals 0. 4 equals x squared. X squared equals plus or minus 2. The numbers that work are in between negative 2 and 2. So down here, my domain is between negative 2 and 2. I actually can't use all real numbers because I first have to be able to plug into this one, get an output, and whatever output I got, I plug it into this one. But the numbers outside of that domain won't give me any outputs to plug in. Okay. I got one for you to try with your groups. Try this one.
You can't simplify past the square root of x minus 5, right?
And notice I switched my composition notation here. I'm using the parentheses. I don't care which you use, just make sure you can read both of them as compositions. If you plug x minus 5 in for x, you just get the square root of x minus 5, and there's really nothing left to do. What's the domain for your composition? Austin, you say? Greater than 5? Could it be equal to 5? Yes, because we can take square roots of 0. So we're going to do bracket 5 to infinity. Now, pay attention to your g. Your g is linear. You can put anything you want into g, right? Negative infinity to infinity. So in this case, the domain of g is bigger than the domain of the composition, but now we have to restrict it by f of g of x because we can't put anything we want in. Okay, you have a homework assignment. You can get started. Remember, there's a pre-calculus textbook at each pod. We've got about 10 minutes, so I want everybody working.